But today I'm going to prove you some proof for addition. I'm going to prove you the proof for addition formula for the trigonometric function. Let's start with sine of x. Sine. Sine A plus B equals what? Just tell you it is not equal to sine A plus sine B. This is not equal. Not true. So what we're going to do is we're going to prove to you by simple thing, triangle. Let's draw a triangle. A, B over here, and we know that from the sine rule, which states that for any given triangle, the side A and B, the area of this triangle is equal to area of triangle is equal to 1 over 2 AB sine theta. Let's label this as theta, the angle between them, sine the angle between them. So what we'll do from this to prove that addition formula, we'll split this into a split this triangle in half. The split is triangle A and triangle B. And as for the angle, this would be A, this would be B. Now from this alone, you can conclude that theta is equal to A plus B. Now, from here, we'll split the triangle. We have split the triangle. Now we'll calculate the area of the individual triangles. We'll start with triangle A. And this will be A, BA. Now the area of this triangle, as you know, we need the base half base times height. Yes, the area of this triangle is half base times height. So what is the base over here? You can just label it as the height of this triangle, H. Half the base multiplied with perpendicular height. Now we know that how to get a perpendicular height? Simply by using sine. Sine A is equals to opposite divided by hypotenuse. The opposite over here can be calculated. Now to calculate the opposite, sine A must multiply with the hypotenuse, which is actually just equals to A. A sine big A is equals to opposite. That's it. Now the area of this triangle, triangle A, area of triangle, the first triangle actually, is equal to 1 over 2 A times H times sine of A. So far so good. Now we can conclude the same argument for the triangle B. We'll draw a triangle B, and this is big B. To calculate the opposite, this must be B sine B. And for the base, it's the same. It's the height. Area of second triangle. 1/2 B H sine B. So far so good. Now, from these two formula, we know that the sum of these two triangles, the sum of the area of these two triangles must equal to the area of this triangle, which is half AB sine theta. Now, I must write that 1/2 AB sine theta must equal to the sum of these two triangles. Okay, we'll write 1/2 AH sine A, and we'll write plus 1/2 BH sine B. Now, obviously we can cancel out half and half here because they all have the common factor. But I need to get rid of AB as well. So how do I convert this and this in the form of A and B? Well, since you know that H over here can be written as this H over here can be written using the cosine. Cos A must equal to adjacent over hypotenuse. Adjacent, since it's H, we got as cos A must equal to H over A, which implies that this H must indeed equivalent to A cos big A. The same argument applies for the B as well. This must be B cos B. Now I need to write them in terms of A and B. So in this case, I must choose the H from the B side. And this H I must choose from the A side so that I can get A and B. 1/2 AB sine theta is equal to 1/2 A. Now this H must come from the B side. AB cos B sine A plus 1/2. Now I must choose this H from the A side. A B cos A sine B. Now we have the common factor, half AB. I can cancel this one out. We'll cancel out one by one. Half 1/2. A are common on all these things, so you cancel that one out. And also B is common over here. So what are you left with? You are left with sine theta is equal to sine A cos B. It doesn't matter whichever way you wrote them, it's the same because they are multiplying. A times B is equal to B times A. So AB is equal to BA. It's the same. Don't have to worry about that. Plus sine B cos A. And since we know that theta is equivalent to A plus B, I can write the conclusion as sine A plus B is equal to sine A cos B plus sine B cos A. This is the proof that we get simply by using the triangle.